This video shows hardware experiments of a particle swarm manipulating a hexagonal object in different trials. This is challenging because each particle receives the same control input. Robots are detected by the overhead camera and are circled blue. The goal is to manipulate the green hexagonal object to the region marked by a green circle at the top left. A maze is made by the long pink rectangular obstacles. The cyan arrows show the potential field of repulsive and attractive forces around the object. These forces are used to steer the mean position of the swarm. The mean position of the swarm is marked with a red star, and the red oval outlines one standard deviation of the swarm. Both statistics are computed only on swarm members in the same region as the hexagonal object. Policy iteration is used to find the best path toward the goal. If the mean position is the head of the object in this path, repulsive forces steer the mean position around the object. All the trials successfully push the objects all the way to the goal. However, due to the stochastic nature of this experiment, the time required to complete the task varied. Object shape affects the time required by the swarm to complete the task. Here, 3 different objects have been tested: a green square object in the top, a circular object at the bottom left, and a hexagonal object at bottom right. Each trial used the same algorithm and programming. In this trial, the hexagonal object is the first, but is only slightly faster than the circular object. We expect this because both objects do not have acute angles and are almost the same weight. However, the square object requires 4 times longer. This is due to the right-angled corners, which increase the probability of getting stuck. Whenever the square object gets stuck in a corner, the swarm cannot pull it out, and the trial is recorded as a failure. In this video, the robots were capable of completing the task, but it took them a long time to complete it. When the square object becomes aligned flush with a boundary, the swarm has difficulty producing a force to pull the object away from the boundary. With hexagonal or circular objects, the swarm can get between the object and the boundary and breaks the connection. This type of failure occurred in all trials with triangular objects. When the object is stuck against the boundary, the swarm often becomes dispersed. Gathering the swarm is a time-intensive activity, but ends with the object successfully delivered to the goal.